the Son, and the Holy Spirit. We are at the end of the liturgical year. It's an occasion to thank God for all the graces we have received this year, especially during this semester. Hail Mary, full of grace, the Lord is with thee. Blessed art thou among women, and blessed is the fruit of thy womb, Jesus. Holy Mary, Mother of God, pray for us sinners, now and the hour of our death. Amen. Mary, seat of wisdom,
pray for us.
In the name of the Father, and of the Son, and of the Holy Spirit. Amen. So we are studying material logic, and this morning we reflect on what is demonstration in science. Because in fact, logic is a science to prepare you for any kind of other science. It's a way of thinking. The man is, we study how we think. We think through three operations, through grasping of things, simple apprehension. We arrive to a definition. We think through judgment. It is the proper central act. It is to judge, to put together concept, a reality, and finally, we have to work, to run discourse, to arrive to a conclusion. That is the reasoning. And we study form of reasoning, categorical syllogism, hypothetical syllogism. All that is a demonstration. Now we study general, now what is a demonstration, and we apply that after to a special dimension, science. Okay? So you go to page 4 in your summary. Nature of demonstrations. So Father Volner, they give you a good definition. It is the legitimate or valid argument. Another word for argument is reasoning. Argument, argumentation, reasoning. So when we reason, it is an argument, it is a demonstration. From evident premises, major and minor, remember, a general principle applied to a special fact, no particular fact, a proof or syllogism that yields a certain or scientific conclusion. And inference. So here he gave you three definitions. And the first is the legitimate or valid argument from evident premises. That's the first definition. He gave you another definition. It is a proof or syllogism. For syllogism is reasoning, it's argument. That yields a certain or scientific conclusion. We arrive to a conclusion from the known to the unknown. And the third definition he gives you, an inference. You remember, inference, it is the logical link, the necessary link between the premises, major and minor, and the conclusion. From certain and necessary premises, whose predicates are essential attributes. Bon, a syllogism, Father Grenier says, a syllogism that engenders science. In fact, every science is preceded by reasoning, by research, and we will see the two kinds of reasoning, in deductive reasoning and inductive reasoning. And those kind of reasoning and demonstration lead us to science. Every science, and any kind of science, they use those two processes, two ways of attaining the truth, induction and deduction. So engender, because demonstration is the cause of science. In fact, we arrive to know because we demonstrate. As long as we cannot demonstrate, you don't arrive to knowledge. So reasoning is a cause of knowledge. A cause of knowledge. And science is certain knowledge of the conclusion derived from certain premises. We arrive from something known through a new knowledge. We start from past experiences, past observation, past reflection, and we arrive to a new knowledge. That is science. It's the reason why science is always in progress. Science cannot stop. Why? Because we cannot stop reasoning, no? we are always questioning, remember that? We are always asking questions. So when we arrive to a knowledge today, now we start from that knowledge we have today, and we try to discover something new. It is the way we progress. Huh? We progress from knowledge to knowledge. Sometimes I say we carry on our shoulders the knowledge of our ancestors. If today we have a computer, because our ancestors were able to count 1 + 1 = 2, you know, step by step. And we are the heirs, huh? We are the heirs of the knowledge of those who study and work and search before us. We should never forget that. Huh? Knowledge is something we acquire, but we acquire from the knowledge of others. We take benefit of others. So from the known to the unknown. Huh? Okay? If we do that to a process, reasoning, syllogism is the perfect model of that. But of course we don't use continualist syllogism. But we think our mind is working. The structure of our mind is a continual machine producing syllogism, because there is no conclusion without a reasoning or without a direct experience, either reasoning or intuition. Okay? Father Jolivet said a demonstration is a reasoning, a syllogism demonstration founded on true principle. Where are those true principles? They are in the premises, especially the major. Most of the time, the major contains the general principle, and leading to a sure conclusion, to a valid conclusion. In fact, here we are deepening, reflecting on syllogism. But we study on syllogism, we try to understand. In fact, that chapter is a passage, is a kind of bridge between logic and philosophy of nature. We are, this morning, making the link. We are finishing studying logic, but we are entering in philosophy of nature, and philosophy of man is a part of philosophy of nature. So various type of demonstration with distinctive probative forces depending on their matter of content. First, we have the called apodictic. Well, apodictic, another word for that, categorical syllogism. The apodictic demonstration, it is what we call categorical syllogism. Categorical syllogism. When the matter involves a necessary, is necessary. The conclusion arrives, it is not probable, it is not possible, it is sure. And we arrive to a necessary conclusion, and that link we call is inferent. That is the big difference between categorical syllogism and hypothetical syllogism. In categorical syllogism, if the syllogism is valid, the conclusion is necessary. We cannot say other thing, impossible. But in hypothetical syllogism, it's not the same, because it is, we suppose something. Maybe what we suppose is not true, is not conform to the reality. Okay, I go back to apodictic. When the matter involved is necessary, that is various terms of the antecedent, the premises, major and minor. You are familiar with that, antecedent or premises. Cannot be related otherwise than they are. They have no choice. If I say, for example, all men are mortal, dictators are men, therefore dictators are immortal. No. I have no choice, I must say dictators are mortal. It is necessary. The inference leads us to a necessary conclusion. It's very strong. It is very strong. But dialectical demonstration or hypothetical demonstration. Here they call that dialectical, but we saw that hypothetical is the same. Okay, so when the matter is only contingent or probable. Probable. If, you know, if. It's not a certitude. If. So that is hypothesis. We call that here dialectical. When the matter is only contingent and probable. So the conclusion also will be probable or contingent. So the conclusion of a hypothetical syllogism depends on the value of the major, you know. If the probability is very strong, the conclusion will be very strong. If the hypothesis is not very strong, but the conclusion will not very strong, you know. But there is no link of necessity like in the categorical syllogism. In categorical syllogism, there is no exception. It is necessary we arrive to that conclusion. Hypothetical opinion. ECE, Plato, most of the time, it's a great difference between certitude and opinion. It's the reason why he did not trust democracy, because he said democracy is based on opinion, not on certitude. The third is rhetorical demonstration. That is used in the past by sophists. You remember, the sophists, they were kind of philosopher, logician. If they were well paid, they can demonstrate anything. That what is true is false, and what is false is true. And that we call sophism. Sophism. So rhetorical. But today it is used in court, for example, by the lawyer, etc. When the matter is such that it involves the emotion, but in a hidden way. It's not a call direct to emotion, but that way of reasoning, that way of demonstrating something, is also hiding the emotion, provoking an emotion. But it's not the first goal. The first goal is not to provoke emotion. But there is, most of the time, some emotion attached to that kind of demonstration. So it's study pertinent to rhetoric. So the expression is important. You know, the difference between a logician or a mathematician. In mathematics, there is no emotion. In mathematics, no emotion. 5 plus 3 equals 1. Cry if you want, there is no reason to cry. Okay? But when there is somebody speaking, demonstrating that life begins at the first cell, it can be a scientific, you know, life begins the first cell. You can say, you know, life begins the first cell, therefore we must respect life, you know. That is rhetoric. The first goal is not to make you be enthusiastic or to make you known, but at the same time is working on your emotion. And most of the time it's the way the politicians work. That is the way of politicians. Politicians, they call and they try to reach your mind, but at the same time you want to reach their emotion, because they are not stupid. They know people vote only for ideas, but they vote also for emotion. That is rhetoric. Rhetoric. Saint Augustine was a rhetorician. It was his first profession. His profession, before being converted, was to be a rhetorician, to teach, at the same time to provoke some emotion. He's a lawyer in the court, you know. He is not like a mathematician. No. When he speaks to the jury, he speaks to the judge, he puts some emotion, rhetoric. Now we have a fourth kind of demonstration. It is especially to provoke emotion. That is we call the poetic demonstration. So when, for example, to excite people to the love of their country, a poet will create a beautiful poem, and the people will learn that, and we put music on that. La Marseillaise, no, la Marseillaise, you know. Oh, French. That is poetic demonstration. The first goal is to provoke emotion. You know, when I was young, in la parish, I was told I was not afraid because it was for adults. When there was a retreat during Lent, some preachers, they come, and when it was the day of talking about hell, they call children and they put them behind the altar. And they say, well, you know, when I will speak about that, like, you will cry, you will, oh, huh? That is that kind of demonstration, to provoke emotion. Provoke emotion. In fact, a comedian is provoke emotion. Okay. But poetic demonstration. We can prove, for example, the beauty of life, the sacredness of life through a beautiful poem, through a beautiful song, you know. That is, it is a demonstration. We want to demonstrate something but using another way. Okay? So preaching, I will say, it is the third one, rhetorical. Because preaching is first is not to move people, is to make people take a good decision. But of course, when you preach, you should move the people also. But a comedian, his first goal, or a demagogue does not call people to reason, he calls people to emotion. And people, they don't know why, but they follow the mob and they become revolutionaries. Okay, the kind of demonstration, I will go now to page 5. The main division of reasoning, deduction and induction. Well, many things maybe will be a repetition, but it is important for your future, your studies. First, a deduction. Well, the division is based on the manner, the way in which the mind argues toward the conclusion. So in deduction, the mind proceeds from a major premise. You remember, in the major we have the general principle. That's the major. And in the minor, we apply that general principle to a fact. Apply to a fact. And finally, the conclusion, we judge the value of the fact in the light of the general principle. That is reasoning. A general principle. We apply that to a fact. We define a fact. And at the light of the general principle, we judge the value of that fact. Okay? I continue. In deduction, the mind proceeds from the major premises, that is more universal, major, and minor premise that is less universal, because most of the time it's an application to a general fact. For example, all men are mortal. That's the general fact. A general principle. Now, dictators are men. That is a fact. Now, we put that together and we see what happened to the dictator when they will die. They are mortal. Okay? In this form of reasoning, the mind proceeds from the intelligible to the sensible order. We start from the intelligible order. That means the general principle, intelligible. And we go here to the fact. The fact is the sensible order. So we go from the intelligible to the sensible. That is deduction. So we start from a universal law and we apply that law. Your mother does that when she prepares. She's cooking meat. All meat must be cooked. Therefore, I must cook this at noon before my children come from the school. You know? So that is general principle. That is deduction. Induction will be the opposite. It is from the sensible to the intelligible. So we start from facts, sensible fact, from facts, or sensible, and we go to intelligible, to a universal law. For example, we have many, we see that tomatoes are you know, 200 years ago, tomato were considered as poison. You know why? Because when they were contained in a thin can, with a stain, what happened with them? The acid of the tomato attacked the metal, and the content became green. So it was considered as poison. But finally, in the 19th century, they discovered that tomato is not poison. So after that, we can use it without danger. So from many experiences about tomatoes, we conclude that tomatoes are comestible. We can eat them, edible. No? We can eat them. In fact, the majority of the general principles are coming from induction. So that is induction. And it is what we study now. We study now induction. Okay? So induction. In inductive reasoning, the mind proceeds from sensible to intelligible. Exactly the contrary. Here it was like that, now we go in the other side. From the sensible to the intelligible. From facts to principle. This sulfur, for example, is yellow. You know sulfur. And so it is the sulfur and so forth. So you go to any kind of laboratory, any kind of industry, and sulfur is yellow. Conclusion, after many experiences, you conclude that the color proper to sulfur is yellow. That is induction. In such a way that when you study chemistry, one of the characteristic proper, one of the inseparable accidents of sulfur is to be yellow. Now, induction, okay? So I goes to the text here. Therefore, yellow is the proper color of sulfur. Induction proceeds by an, very important, enumeration of the subjective part of to a knowledge of the whole. So we start from the subjective part, that means the individual case, and we arrive to a law for the whole, No? That is induction. We start from the individual subjective, individual part, one by one, and finally we arrive to affirm for the whole, the universal. Yes.
I didn't think you could go from the part to the whole in truth.
Yes. Okay. We saw your question is good. We cannot go from I to A. If I is true, can I say about A?
Unknown.
Okay, unknown. But are you? You know, in fact, it is true that we cannot start from a certain number. But induction, that is, you touch the central problem. How we can affirm that induction can produce truth? So the condition is a sufficient enumeration. A sufficient. But the problem is, what is a sufficient enumeration? Is the reason why induction is never absolute. Is never complete. Except if we can measure. For example, for me, it is easy to have here a complete induction. Are you Catholic? Are you Catholic? Are you Catholic? Therefore, all my students. Okay, no problem for that. But when you have a million of cases, so what you do, you start from a sufficient enumeration. But you are aware that the conclusion of induction has not the same strength as the conclusion of a deduction. In a deduction, the conclusion is absolute, necessary. In induction, the conclusion is always approximative, probable, very vague, 99.9. 99.9, as they say on television, they speak with their nose. 99.9, 99.95 cents. But they left 5 cents. 5 cents. There is always a margin of indetermination. And that is the reason why there is always a possibility of miracle, of exception. We come back on that. It's a very, you touched the central problem. Yes?
Is like a critical mass of something? If you have a critical mass, you can make a determination.
Yes,
about the
but even in the subatomic because word in science, there is always possibility of error. Always. Is the reason why today scientists, serious scientists, never affirm exactly. This is the question. They say, for example, 500 plus minus or 2, for example. That means there is a margin of error because they know they cannot measure everything. But they are. But that is, it was not approved by the positivists. The positivists of the 19th century. They said we arrived to absolute certitude. They pretended to arrive at absolute certitude. That is not true. Today, scientists, especially since the Mr. Heisenberg, is a German, discovered the principle of indetermination in the subatomic world. That means we cannot arrive at absolute. That means not a single induction, incomplete. Okay, there are two kinds of induction, complete and incomplete. Of course, complete induction, no problem. We can arrive to a absolute certitude because we can check every case, okay? But when we cannot check every case, we are in the domain of probability. We can arrive at 99.9, but there is 0.1. We don't know. There is possibility of error. There is possibility of accident, etc. Okay? It's a way for a company who produce medication, for example, to say, no, it was not absolute perfect. We preview the possibility of an error, of an accident. No? But you are the bad guy, you fall on the wrong product. Okay, I go back to the text here. There is a theory of induction in the organon. Organon is meaning in Greek the instrument, the tool of Aristotle. In fact, Aristotle taught, called his book of logic organon. That means the instrument. Logic is the tool. Interesting. Logic is the organon, the tool. It is a passage from particular to the universal. Induction has at least 3 different meanings in Aristotle. The first meaning is didactic induction. It is to teach. I use that many times in class. When I use example. I use example, and from those examples, you try to understand the general principle. Is to teach. Jesus used that also in the gospel, using the parable. Secondly, it is the abstraction of universal from particular sensation. That is what here. We start from particular sensation, particular facts, because we know facts, we know through our sensation, to a universal concept. That is the proper meaning of the one we study now, induction. And the third one is the generalization induction. In fact, we start from from I and we go to A. But the 3 are similar. The 3 are similar. The first is the most used by teacher, by preacher, by parents. We use cases. You say, the little boy there, he is sick. You know why? Because he ate too much chocolate. Be careful. He is sick. Now that is induction. Didactic induction. Your mother used that. She does not know she is a logician, but she used that. Okay, continue. Induction differs essentially for the deductive form or reason. when we resolve a conclusion into intelligible truth, upon which it depends, we are proceeding deductively. When you start from a general principle and we take from that an application, that is deduction. But when in induction we infer, we don't take from, we enter, Infer means to carry. Fero in Latin means to carry. Carry. So infero, they mean to carry in. So we start from some facts, and we arrive to a conclusion. Last Saturday, there was a beautiful Hispanic fiesta. Even if it was Hispanic fiesta, there was also Vietnamese fiesta. And I saw Vietnamese sisters dancing. I conclude that all sisters in Vietnam, they dance like that. It is an induction. Induction. I start from facts and I generalize. We understand that, no problem. What I'm doing now, I am using a inductive. I am using the didactic induction. Didactic induction. In fact, we use that a lot. We start from some cases. We know people can understand. We call that example. Samples. Okay? Now, induction differs essentially from the. Okay, we saw that. But when we resolve a conclusion into an intelligent truth upon which it depends, we are proceeding deductively. Okay. Now, here, in induction, we infer a universal truth from sufficiently enumerated singular cases. That answers your question. Sufficiently enumerated singular cases. That is the central condition to have a right induction. But the problem is always the same. What do you want? What do you mean? What do you think it is a sufficient enumeration? That is the problem. It is necessary that we note the essential difference between deduction and induction. Induction is an original kind of reasoning. Is not deduction. Induction is a real reasoning, different from deduction that is a reasoning. It is not a disguised form of deduction. When we deduce, when I start from a general principle applying to a fact, arriving to a conclusion, we have some middle term, which is the link between the premises which the conclusion follows. For example, every man is mortal. John is a man. So what is the premise, what is the term allowing to arrive to a conclusion is the term man. Therefore, John is mortal. The middle term is a man. But in induction, what is the middle term? That is important. It is the enumeration of individual, of parts. Now, I give you an example. I don't need to go to the gym. It's a good exercise for me, but after the class I will not be in occasion to practice. So if I say, you study chemistry, iron, you understand the symbol in chemistry? Yes. Iron, fair, iron, copper, aluminum, silver, gold, and nickel. Okay? Well, I have many pieces of many different metals, and I have two of wire here, and I have a lamp there. So when I put a piece of copper, the current passes, the light is on. All that produce light when they are electrified. So I can see they are conductor of electricity. Okay? They conduct electricity. Well, that is a fact. I can check one by one. Now I can say iron, copper, aluminum, silver, gold, nickel are metal. What is the conclusion?
Metal.
Metal are good conductor of electricity. Okay? Well, the way of proceeding in deduction is not the same as in deduction, but there is a kind of middle term. What is the kind of middle term? What is that? A sufficient enumeration. The sufficient enumeration. So if the sufficient enumeration plays the same role as a middle term, the same role as a middle term. But you remember, a middle term must be at least one universal. Of course, here, maybe it's difficult to use plutonium in my laboratory because it is radioactive, radium. So I conclude that all methods, but I don't make the experience with each one, but I make an experience with a sufficient number. But there is an exception. An exception that is not a metal, that is a non-metal and conduct electricity. What is that?
Insulator.
There is a non-metal, conducting electricity. Carbon.
Oh.
Carbon is a non-metal. You know, interesting, you have an exception. I cannot say only metal conduct electricity. No? Water.
Sure.
And try that in your bath. We call 911. You know, water conduct electricity. The reason why never use a radio or something, an electric appliance device in a bath or in a shower. And because it is the direct way to go to heaven.
So Thomas Merton died.
So I mean, interesting here. The conclusion is metal conduct electricity. And when you teach chemistry, you are not a teach because you know that carbon, it is black. It is not bright at all. What is the characteristic of metal? It is the brightness. You cut metal, it's bright, bright. But carbon is black. Interesting to prove that, you know, it is always room for exception. Always room for exception. Okay, I come back to the text here. So we have a complete or incomplete in that answer the question. Sometimes we can verify one by one. For example, I can verify one by one. It is what they did when you enter the United States or you enter the seminary. One by one, you have to give your ID, you give your information, you know. One by one, we check if you are Catholic, etc., etc., etc. That it is a complete induction and enumeration. But, for example, when the people arrive in, in Peru, I was in Peru for a few times. When you arrive to the airport, there is a button here. Each one arriving, push the button. Okay, welcome, push the button, welcome, push the button, hey, go there. You know, that is, they cannot check everyone, but they take some sample. So someone are examined, they open the luggage, but they have no problem. That is incomplete, because it will be so long. It is exactly the same problem with container. And you saw in picture at least, big, huge container. Someone longer than 2 or 3 football ground, huge, filled with container. Can we check everyone one by one?
Yes.
We can, but we don't do that. It takes months. So what they do, they take sample. if you have an insufficient enumeration, of course. So the induction, you can say, oh, that ship is safe. Yes, it's safe, except we did not check every container, you know. No? It's the same at the custom. They don't open all the trunk of the car. Huh? They look at you, you're a sympathetic, oh, good man. Open. You know, so you understand now? In induction, if we can verify, that is possible when the number is limited. When the number of cases is unlimited, we proceed by sample. By sample. It is exactly what they do now for the electoral campaign. And every week you will have the result of Mr. The big shot, Trump. As such, that is based on incomplete enumeration. And if you are attentive, they say with a margin of error of 3% or 5%. That means if they have 35%, but the margin of error is 3, that means we can say they are between 32 and 38. You know? That is margin. Sometimes the margin of error is more than that. Last campaign in Canada, we have a young prime minister, and all the polls put him in the. Maybe he will win with a very, very low number of deputies. I'm in Canada representatives with minority government with minority, but he have a huge majority. All the polls were wrong. All the polls were wrong, you know. That means the margin of it and the margin of can be very, very wide. That means we don't arrive to absolute certitude. That is the limit of probability and the limit of induction. And the reason why continually the company, they are never satisfied. They check continually the value of their product. A good example, GM recently, or they took back like a Volkswagen, hundreds of thousands of cars, because they realized there was a danger in the car, you know. So they were sure it was the best car, but after that, oh, accident, oh, bring back the car, you know. So, of course, not every car is dangerous, but because many cars were dangerous, so they expend billions of dollars to repair those cars, to change the device. Okay, next page. So we can see, we want page 6. So the desire to know its property, which are true of all sulfur. We want to know the property of not this sulfur, but every sulfur. Not this cat or every cat. How we can say cats are good mouse hunter? Because we saw cat. My mother said that. My grandmother said that. And it is in the dictionary. Wikipedia said that cats are mouse hunter. Finally I say, but is it possible that some cats are so well fed, so obese, that they will not move to capture? Why I will run after the cat? I have a big meal every day without any effort. But that is exception. You know, induction must accept exception. There is always possibility of exception. But deduction, no exception. No exception. Okay. Now the fundamental. So we can say, I go to the third line. The induction is a valid form of inference, but is not properly demonstrative. That means it demonstrates for the majority, but not for absolutely every case. So there is a possibility of error. And, you know, it's important for us as Christians. We must affirm that the scientific laws are not absolute. Otherwise, if you affirm the scientific laws are absolute, there is no more possibility for exception. I give you an example. You have the law of gravity, no? Okay? That book cannot jump at. But suppose my book float in the air. Oh, a magic book, magic carpet, you know. But it happened, no? Happened. In the life of Padre Pio, I think, he entered his room and the chair was floating and you know, of course the devil, but he was an exception. And Saint John de Cupertino, who saw that recently, Saint John de Cupertino was a very pious, but he was floating. And one brother, his mission was to check. Hey, don't fly because we don't want to take airplane to catch you. You know? Exception, yes. And otherwise, it is absolute. No, God is the creator of natural law. Those natural laws are not absolute. He has always the capacity to make exceptions, to suspend the application of the natural law. Okay? This fundamental principle in induction. So it is. What is true of many enumerated parts of a universal subject? When these are sufficiently enumerated, it is true of the universal subject. We saw that just before. That is the central principle. And the problem is here. What is sufficient enumeration? That is the problem. If we do not sufficiently enumerate the part of the universal in reference to predicate, we cannot attribute this predicate to the universal. That means we cannot give a universal value to a thing, to a fact, to a principle if there is possibility of error, of exception. So we must say, yes, it's a valuable principle, except, a good example in physics is the dilatation of core, of body. You know, when you warm a piece of metal, what happens to the piece of metal? Dilate, Dilate, we see?
Dilate.
Dilate, dilatation, expand, okay? But there is an exception. Contraction. Normally, a hard body, when it is cold, you contract. You do that, no? When it's cold, this sister is... when you are cold, contract. But one product does not contract. On the contrary, one is the dilate. It is the water. And that is exception. Why? We cannot explain that. Nobody can explain it. That escaped totally to science. We try to explain that. Happily. Water is dilating, we see?
Expanding.
Yes, expanding. Because imagine if water was contracted, what would happen? All the fish would freeze by the bottom. and the river will become a black of ice. No, it's the contrary. Okay?
But Father, sometimes we heard the two doesn't belong to the greater number. How we can explain it?
The two
doesn't belong to the greater number.
Exactly, because of that. It's not because the many have felt something, the thing is true. What is truth? Conformity to my mind, to the reality. The measure of truth is the reality, not the number. And that is interesting question, because many times we refer to induction to affirm values in ethics, in moral. We say, all people do that. And now, for example, since 10 years, half of the young people don't marry. And now more and more. But they will be half plus one, they will be the majority, therefore they will make a new law, a new principle, and the number will say, no, marriage is not necessary to have children. No, marriage is not necessary. You know, the majority does not make the law. So that is it is only a parallel, an allusion. But here we are talking about the number. Okay, I go to the next paragraph. The problem, I already explained that. But there are two kind of relation between a predicate and a subject. Remember, subject and predicate. If the relation is essential, or if the relation is accidental. Essential, when the predicate is united to the subject as a genus, specific difference, and species. And we also add property, because property flow from the essence. And the other are purely accidental, no? Purely accidental. So that is important here. Because if I have only one case, and that case is the predicate has an essential link with the subject, that case is a universal principle. I give you an example, taken from the Bible. God created one man.
Yes.
Was Adam a man, a real man, because he was only one? Yes. Because it was essential for Adam to have intellect, to be able to reason. You know, only one man was sufficient to have a universal principle, because the relation between the predicate and the subject is essential. You know? But was it essential for Adam to commit original sin? No, not at all. Because it was essential, he would not be free. And he was free. No? So interesting to see. We saw that before. When the predicate is united to the subject in an essential way, if you have one enumeration, is sufficient for everything. For example, on Earth, how many suns in our system do we have? Only one. So when you speak about the sun, we see the sun is very warm. Don't be careful, the sun is dangerous for cancer. Is it a universal affirmation or an accidental affirmation? It's universal. No, that means when the relation between the predicate and the subject is essential, it's not necessary to have many individuals. Only one is sufficient. But most of the time we have many individuals. Many individuals. Okay. So that is non-essential. In one, the relation between the predicate and the subject is not essential. For example, I say seminarians are pious. Seminarians are pious. I saw seminarian. I said, oh, they are pious. They are pious. Okay. Can I say all seminarians are pious? No. No, I cannot. Why? Because the relation between piety and seminarian is not essential. It's not essential. But if I say seminarians are Catholic, baptized Catholic, that is essential to be a seminarian, to be baptized Catholic. So it's sufficient to have someone to affirm for everyone. Okay? So you see the difference we started last week. God is merciful. John is merciful. In the case of God, mercy belongs essentially to the subject God. But John is merciful. Mercy does not belong essentially to John. So I must have many cases of merciful people to affirm that that kind of people, for example, priests or sisters or Catholic, are merciful. Okay? Though the result of that is probability. When we speak about induction, we are on the domain of probability. Okay, I go to the next paragraph. So experiment is more than observation. Just before the last sentence, in fact, how we can know a thing is probable when it is when we have many experimentation, many observation. So observation is I watch a phenomenon. I watch a phenomenon. Experimentation or experiment, not only I watch the phenomenon, but I think about, I reflect on it, I measure, I control. It is experience with control. That's the difference, for example, between the farmer and the agronomist. The farmer will make many experiences, but he does not measure, he does not control. He says, oh, you know, this year I had more corn than last year. But the scientists, what they do, you see, last year we have 2 tons of corn, and this year we have only 1.5 tons of corn. How is it possible that this year we have less corn than the year before, you know? That is observation plus control. So observation with control gives experimentation. That means it's sufficient to have some experiences, some observation. We must reflect on that experiences. And that is the condition of progress is not to have experiences. People have experiences since the beginning of the humankind. But when someone reflects on the experience, that becomes experimentation, observation. A good example of that is Mr. Newton, you know, with this apple, no? But not apple of Guillaume Tell, the apple of... It's funny, apple, Adam and Eve, apple, and Guillaume Tell, apple. You know Guillaume Tell? William Tell? With the apple on the head of his son, June, and apple or Newton. Apple, and okay. So he saw an apple falling on the floor, fall, two. Everybody saw that. You know, I sent you a little video with elephant, and giraffe. So they saw many apples, but not a single elephant, not a single giraffe asked why the apple is not falling up. And Mr. Newton, he was eccentric, bizarre, he was weird. See, how is that? Is that guy stupid? You know, suppose you were with Mr. Newton. You see, why you had that stupid question? Why the apple is not going up, but it's going down? But because he reflected on that, he discovered one of the most important laws in science, the law of gravity, universal attraction. You know, it's interesting, huh? To see little fact, someone go and reflect on that. The other say, oh, stupid Newton, imagine that guy. Huh? The people laugh at him, I'm sure. They laugh at him, they say, yes. Think about that. And you arrive in the refectory, you say to your sister in the monastery, your sister, why the apples are falling down and not falling up? Try that. And they will say, sister, we don't have that question. It's not when they fall down, really. Why? And you can explain that. Okay. You know, that is, wisdom comes from that. Wisdom comes from reflecting on our experimentation, and science also. In fact, science and wisdom, they go together. They should go together. Okay, I go next paragraph. So the inductive method of experimentation is often begun in the light of some hypothesis, which is more than a reasoned guess or brilliant intuition. It is a provisional explanation of some phenomenon, founded on more or less probable argument, and all as provisional, temporary, until it's verified and approved or disapproved. So science proceeds like that. We find an idea explaining a phenomenon, and we try to check if it is true or not. If it is true, we will continue. If it is not true, we search another way of explaining a phenomenon. So that is the definition of hypothesis. Okay? So in the experimental science, the method of inference is not always purely inductive. In fact, science, of course, they are at the beginning inductive. They start from experimentation, cases, but they are also using deduction. And the majority of science, they use mathematics. What is mathematics? It is deduction. Secondly, every science, after a certain time of experimentation, after proving the value of their discovery, what they do, they make a general principle and they apply that to everyone. A simple example, the company Bear, produced by Tiny Lol. There, Tiny Lol. Tiny Lol, no, Tiny.
T-Y-L.
Huh?
T-Y-L-E-N-O-L.
T-Y-L-E-N-O-N. Tiny Lol. Oh, today they can say Tiny Lol is good for headache. After a class of logic, you see, I need a Tiny Lol. how they can arrive to affirm that? That takes years and years and years. Recently, a scientist spoke about a product. About it was to clean the floor, a special device, very good. He said, I produced 1,000 of devices before putting one on the market. Those companies, they take 10 years and more to produce tiny law. And you know, that is, they arrive to a certain general law. Now, because tiny law is proved to be good for toothache, you go, you say to your superior or sister, or, oh, my mother, oh, I'm tired. You know, I study logic all the evening. Oh, my sister, I have a good thing for you. Take a Tylenol. No? So Tylenol is now is used for the headache, so you can apply that. So, in fact, it is inductive, deductive. Inductive at the beginning, but the discovery they did become a general law, and you can apply that to your headache. Okay, so and we can see they are deductive, inductive. Huh? Deductive, inductive. There is no pure inductive science. Why? Because every science pretends to arrive to a universal conclusion. No. So they must arrive to that. For example, Newton arrived to the general law, universal law of universal attraction, gravity. Gravity. Now we can apply that to many things. It is because we know the law of gravity that we can go on the moon, on Mars. We can go because we know not the law of gravity. And we can send a missile against ISIS from the ship because we know the law of gravity. You know? Okay. So a rational, the next page, page 8. Well, here it is an explanation of what I explained already. You remember when I explained those induction, deduction, and also that chart. Yeah, that. The chart I explained, demonstration, rational demonstration, and when I explained experimental demonstration. You remember that? On that. The 2 pages here are explained line by line. So I will not come back on that because I already spent almost an hour for that. So analytic, synthetic. Remember, analytic, God is good, that is it is analytic. John is a good golfer, that is synthetic, etc. That page is very important. On page 10, and 9 and 10, you have the explanation, you have the rational demonstration explained line by line, and you have the experimentation described line by line. I go to page 11, science. Now, science has 2 main meanings. The first meaning of science is to have a knowledge, to know something. So science is the, for example, I can say the synthesis of all knowledge about the phenomenon, about gravity, for example, about heat, etc., about the speed of light. So it is the first. A certain intellectual knowledge of something in its causes. In its causes. So it is a knowledge of something, a content. It is also a habit. Science is a habit. It is intellectual virtue. You remember what is a habit? A habit is an acquired operational structure. A tractor can do nothing if there is no something added to the tractor. The tractor cannot cut the grass, it cannot plow the snow, it cannot haul the wagon if there is no device attached to it. So we must structure the tractor. So we must structure the senses or the faculty. That is to acquire habit. We have the 4 cardinal virtues are habit. the virtues of prudence, the virtues of justice, temperance, fortitude. They are good habit, helping man to know what to do and to have the courage to do what he has to do. So, habit of knowledge. It is a stable disposition acquired by means of demonstration. So, we acquire the habit through making syllogism, to making demonstration. Like I acquired the habit of teaching from the fact I began to teach. The first time I taught, I was not so secure that I am today. No? Yes, it's normal. Huh? The first time you will preach in the parish. Huh? Yes, but the more you will preach, the more you will know how to preach, the more you will become a second nature. Huh? A second nature. It's the same for prayer, it's the same for meditating. Huh? So it's the same for science. So science is a habit. Huh? The habit of using experimentation, reflecting on that, etc. Okay? So it is also the content. We call the content of the body of truth. Huh? All the conclusion are attained through experimentation. All the conclusion. You take a book of physics, you have many conclusions. All those conclusions about electricity, about heat, about coal, about magnetic, etc., are in the content we call that science, a book of science. But when a student is searching, a scientist is working, he acquires the habit of science. So science is a habit, science is the result of that habit, what I acquire. Okay? So now you have speculative and practical. Speculative, it is to contemplate the truth. Speculative, it is to do something, to produce something. Huh? Okay? I go now to the material object of science. So in science, we study many science can study the same material object. But each science has a formal object, a specific, formal, specific. A specific object. For example, man is studied by doctor, biologist, is studied by philosopher, studied by theologian, anthropology. So man is the subject, is the object of many science, but each science study man in a formal point, at a particular point of view. Okay? Now, when we say that, we arrive to speak about the 3 degrees of abstraction. Because, if a science study an object in a particular way, in a special aspect, the science must apart the rest, no? And that is, we call first, we study in philosophy of man, abstraction. Abstraction. So, abstraction, it is to abstract, to take from, but to take from, I must put apart. For example, when you go in your drawer, we see drawer, and you have all your sweater there, huh? And you want a red one. Today I want to wear a red one. And it is under the pile. What you do? You take and you abstract. But when you do that, all the other come with it. No? You put the other and say, hey, I don't want you. I want But that is abstraction. Understand that? Abstraction implies you fix one aspect of the reality, but at the same time you put the other apart. And we have 3 levels. The first level is first degree, the degree of philosophy of nature, and you have that also in that page here, the degree of abstraction. You have that here. It is to center, to detach from individual sensible matter. We put apart everything that is singular, that is individual, but we keep we call it physical abstraction. That means we detach from individual matter, and we keep what is universal. For example, I look at my cat. Well, my cat has a fur, he has 4 legs, etc. So I put aside my cat. I know a cat has a fur, but my cat is that kind of fur. It can be large or little or almost nothing. That I put aside the color. I put aside the form of his eye. You know, some cats are like that, etc. So I put the detail. I arrive to an idea, a concept of cat that can be applied to the universal reality of cat all around the world. So that is the first degree of abstraction. You know, you see, and it also refers to abstraction of war. In fact, I want to arrive to the whole species of cat, and to arrive the whole species of cat, I must detach every cat. My cat, my grandmother, no, the cat in. But the cat here is sensible, not this cat, but every cat continues to be sensible in general. But if I detach sensibility, I detach what is sensible, I consider only quantity. The cat has a volume, the cat has a speed, etc. That is second degree of mathematics. I consider only the quantifier, the quantity in the cat, the volume, for example, the length, the weight, etc. Independently of this cat with that cat. That is second degree of mathematics. That abstraction. In mathematics, we don't attach, it can be anything. And finally, we are into the third degree. We put aside even quantity, and we keep only meaning and existence, being. Being. Meaning of thing, existence. Thing exists, and because they exist, they have a meaning. That is metaphysics. We don't refer to the color of the cat, we don't refer to the way of the cat, we refer only to the existence of the cat. Why the cat exists. That is the third degree of metaphysics. And finally, you have some science, they mix, they use many aspects. In mathematics, for example, is in every science. Almost every science, almost, not everyone, but almost use mathematics. So between mathematics and the particular science, for example, between mathematics and physics, we can have a mixture of both, mathematical physics. In fact, we cannot study physics without knowing mathematics. You know, it is a big problem in the United States. President Obama underlined that many times in his speech. In education, we are lacking of mathematicians. And we have to take mathematicians from India and from China. The children today don't like mathematics. And one of the reasons, because the computer does everything for them. That is a big problem for a society. When a society is obliged to search mathematicians outside, so we should, mathematics are very, very, very important. You know, I am a philosopher. No, I am a teacher of philosophy, but I convinced to the extreme importance of mathematics. A community will be in bankruptcy if the bursar will not know how to calculate. No? And yes, and what you do when you want to know if you are in good health, you walk, you climb on a scale and you look. It is only one person at a time. You weigh. What is to weigh? It is calculate. In fact, your wallet, you say, I have money? No, I have $50. You don't say, I have money. $50. So mathematics are very important. Even for the Holy Trinity, 1 and 3. Just 1 and 2. Okay. And finally, you have the element now to be able to take the class of metaphysics. Because everything we study during the semester, all the concepts we study, they will be studied again in metaphysics. But you have the first knowledge. And don't forget that, huh? And anyway, you will not forget that. You know why? Because you will use them in other subjects. You will see that. You will see Father Legault was alright. Huh? Knows best. He knew best. Okay, next class we practice.